Hello? 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 Hello?
Hello, Dr. Satish.
Krishna Rao, sir.
Am I audible?
Sir.
Chiranjeevi, good morning. Am I audible?
Good morning, sir. Yeah, yes, sir. Audible, sir.
Yeah. Okay.
Can we start, sir?
Yeah.
Okay, sir.
No problem.
Anil, sir.
వాళ్ళకి కంప్లైంట్ పెట్టాలమ్మా ఈవెంట్ జరిగితే వారంలో కంటిన్యూస్ ఇవ్వండి
Anil, sir.
పెట్టుకుంటే అప్పుడు ఇస్తారు
Anil, sir. Ravi, sir.
హలో సార్ సార్
సార్ ఒక స్టార్ట్ చేసుకోవచ్చు. అనిల్ సార్ స్టార్ట్ చేయొచ్చా?
చేయొచ్చు సార్.
ఓకే. Sir, we are going to start the session, sir.
Yes, please.
Good morning, everyone. On behalf of the Department of Civil Engineering, I extend a warm welcome to all participants of today's webinar on Industry 4.0 Driven Innovation in Pavement Engineering and Sustainable Road Construction. We are privileged to have with us our guest and speaker, Dr. S. Krishna Rao, whose expertise in transportation and sustainable infrastructure will certainly inspire us all. This program has been specially organized for our students to explore the role of advanced technologies in shaping the future of civil engineering. Before we proceed, it is my honor to invite our respected head of the department, Dr. C. Chandrasekhar sir, to deliver the welcome address and share his thoughts on today's theme.
So very good morning to Ananda.
Sir, good morning, sir.
Good morning, Krishna Rao. Namaste. How
Namaste,
are
sir.
you?
I'm good, sir.
Okay, sir. We are very fortunate once again. Our alumni, Dr. Krishna Rao, S. Krishna Rao, is of our alumni member. Presently, he is working as a professor and head of the department, BVRIT, Hyderabad. He is a very close association with our Dean Satish sir and myself. He is a very long service in the field of transportation. He executed not only the academic lines, he also very active in participating the consultancy works and the real-time works. So he is a good one. Today, we are very fortunate to share his ideas with our students. Anyhow, being an alumni, he has to guide the Bapatla Engineering College students in the right line and what are the bright future, particularly in the area of the transportation engineering. Well, from my observations, transportation is in a wide area, transportation systems. It is inevitable because day by day the population has drastically increasing. Everybody wants to their fast. Everybody is the quick and fast services. So for that, whether the system is available or not, is is supporting the existing roads or any railway systems or airport systems, or whether they are supporting or not, we have to check it. So how to imagine and how to uh, aim for the future generation. So hoping our Krishna Rao is will cover all these points to enrich the knowledge of the property engineering college students. So we are waiting, eagerly waiting for your lecture. Thank you. First of all, first you thanks from the Bapatla Engineering College for ready acceptance because the schedule is very busy in your college, just like our Bapatla Engineering College. Every minute is very tight, but uh, thanks for your cooperation. Actually, the schedule is the program is scheduled on yesterday because of some constraints and some delays. So it was postponed to today. So sorry for that inconvenience caused to you. Okay, Krishna Rao, thank you.
Yes, sir. Thank you, sir. Thank you so much.
Thank you, sir. Now I would like to invite the person who arranged the event, the Dean of Academics, Dr. CHN Satish Kumar sir, to address the gathering.
Hello.
Yeah,
Good
yeah,
morning.
your voice is audible. Satish, sir,
Good morning,
please
Krishna
proceed.
Rao.
Good morning, sir. Good morning.
Good morning, one and all. Actually, I'm very happy because Krishna Rao and myself joined in this institute in the same year. Almost he also worked in this institute about 5-6 years and then moved to Siddhartha Engineering College and then moved to Hyderabad. But he's very friendly nature and he's also most experienced in the consultancy also. So definitely already in the faculty development program, you covered all the topics here. So one is not covered, that is the pavement engineering. So that is covered by the S. Krishna Rao. Definitely, this lecture definitely will the knowledge from this lecture is very useful and gain some knowledge to all students. Thank you, Krishna Rao. Thank you,
Thank you, Dr. Satish.
thank you, one and all.
Now I would like to request the one of the coordinator for events, Chiranjeevi sir, to kindly introduce our guest speaker by reading of his profile.
Morning, everyone. It's a pleasure to welcome you all to this special session today.
Before I invite our distinguished guest, allow me to share a brief glimpse into his remarkable journey. Dr. S. Krishna Rao, alumni of BEC, batch 94-98, obtained his master's degree from SGS ITS Indore in 2000 and PhD from JNTU Hyderabad in 2016. Presently, Sar is currently professor and head of the Department of Civil Engineering at B.V. Raju Institute of Technology, Hyderabad, where he has been shaping minds and advancing research in the field of roller compacted concrete for pavement applications using different mineral admixtures and alternate fine aggregate and industrial waste. His research interests include special concretes for paving applications, use of waste materials in rigid and flexible pavements, planning and design of rural road pavements, soil stabilization, etc. With over 23 years of experience. He has published more than 45 research articles in several peer-reviewed journals and conferences. He authored one textbook titled Road Material Testing and Pavement Evaluation, and he is also co-authored a textbook titled Behavior of Reinforced Cement Concrete and Steel Industrial Chimneys. Currently, he is a reviewer of several peer-reviewed journals. He has been a keynote speaker at numerous international conferences, and his work has not only influenced academic circles, but also impacted real-world applications. He has been providing several consultancy services in the area of traffic and transportation engineering, pavement design, job mix formulas, mix designs, and material testing for government and private organizations. He provided third quality control services to Vijayawada Municipal Corporation, CRDA of AP, VGTM Buda, Nellore Municipal Corporation, Guntur Municipal Corporation, etc. Today, he will be speaking to us on the topic of Industry 4.0 driven innovations in pavement engineering and sustainable road constructions, a subject that resonates deeply with current developments and future possibilities. So without further delay, please join me in giving a warm welcome to Professor S. Krishna Rao, sir. We truly honored to have you with us. Please take the session, sir.
Yeah, thank you, Mr. Chiranjeevi. Good morning to one and all. Respected HOD sir, Dr. Chandrasekhar Rao sir, and my colleague, my friend, Dr. Satish Kumar, and faculty of Civil Engineering Department of Bapatla Engineering College, and my dear students. Welcome to this keynote session. Dr. Satish invited me to address the students of Bapatla Engineering College, final year, third year, and second years, just to introduce some key topics in the area of transportation engineering. So I have chosen pavement engineering, being specialized in pavement technology. I wanted to address some important issues in front of the student community. Before entering into the actual presentation, I want to thank Dr. Satish Kumaru for inviting me for this session. And I also want to thank Dr. Chandrasekhar Rao sir. I just wanted to brief about my experience as a teacher, as a consultant, and as a researcher. I have, as Chiranjeev sir mentioned about, I have an experience more than 23 years in both teaching as well as industrial consultancy. I did my PhD from JNTU Hyderabad under the guidance of Dr. Chandrasekhar Rao sir. He is your HOD. Thank you, Dr. TCR sir. You provided valuable guidance during my research activity at JNTU Hyderabad. So I did my research in the area of pavement engineering, where the industry byproducts usage will change the pavement quality and pavement durability. So I just studied the pavement maintenance, pavement quality, and pavement design in my entire research. So in that particular aspect, we have chosen several industrial byproducts, and I just characterized all the byproducts. Accordingly, I optimized the mix design based on the available limited resources. Now, I have chosen this topic, Industry 4.0 driven technologies in sustainable pavement applications, just because of my research area is very close to the sustainable pavement engineering. Yes, I wanted to share my presentation. Is my screen visible?
Yes, sir. Yes, sir.
Yeah. Thank you. Yes. This is my today's topic. Yeah, Industry 4.0 driven innovations in pavement engineering and sustainable road construction. As Dr. TCR sir mentioned, transportation engineering is a big ocean. So we cannot cover each and every topic under transportation engineering, as it is a field of every civil engineering specialization. So out of various specialization, I have chosen pavement engineering topic, and how this Industry 4.0 driven innovations are connected to the pavement engineering in general and the sustainable road construction in particular. Okay. Now, prior to the presentation, all the students who are listening to my session, varying from second year to final year, for some of the students might have studied the pavement engineering, and some of the students might have studied concrete technology. So this presentation will suit to the needs of all students varying from second year to final year. So my presentation is restricted to the basic sustainable technologies available in pavement engineering, right? And as far as your curriculum is concerned, your BTech program in the first year you might have C programming and the laboratory Python programming laboratory. You might have some subjects relevant to introduction to artificial intelligence, and even if you can look into the professional elective courses, they might have some machine learning applications in civil engineering, and you might have some subjects relevant to Internet of Things, IoT. You might have chosen some of the subjects of other departments as open elective courses, like data analytics, data science, etc. and etc. And some of the colleges, engineering colleges, both in Andhra Pradesh as well as Telangana, are offering minor degree programs in addition to your major BTech civil engineering. You might have heard about the minor degree programs also. That means while studying your BTech program in civil engineering, you might have choose the minor degree in artificial intelligence and machine learning, or otherwise minor degree in data science. So most of the colleges are offering these two minor degrees. The idea behind introducing these minor degrees and the idea of introducing some of the computing technology subjects in BTech curriculum in addition to the regular civil engineering subjects is to make you familiar in understanding the digitalization in the construction industry, digitalization of infrastructural development. So that's why these many courses have been introduced to you. And if you can look into the project programs, project works, either major project or mini project, and some minor projects in your basic curriculum, some of the students might have done their project work using artificial intelligence or using Python coding or using C programming skills, etc. And you might have used StatPro for your design analysis and design of some civil engineering structures. And if you can look into the modeling softwares like building information modeling, Revit and SketchUp, kind where we have exposed to a lot of modeling softwares, etc. So, and again, you are familiar with the AutoCAD, two-dimensional AutoCAD drafting or three-dimensional AutoCAD drafting, etc. So the idea of introducing all these things is just to familiarize the digitalization that has been taking place in the construction industry. So all the students who are studying BTech Civil Engineering must be familiar with these innovations, these digital tools, soft computing tools in civil engineering, etc. So, being a civil engineering faculty, I can explain the concepts of civil engineering in general and concepts of transportation engineering in particular. But I may use some of the tools available in the digitalization market. So I'm clubbing both digitalization as well as a civil engineering concept into one program so that you can do some wonders in the civil engineering career. So you must know all these innovations, all the digital tools available in the market, and then use these in the construction industry. So previously, the civil engineers are capable of doing designs and dealing with the construction. That's it. But nowadays, we need the accurate designs, uh, optimized proportions in concrete mixes, etc. So all these things will not be happen manually. So one need to use some accurate tools so that they can optimize everything. So in that case, Industry 4.0 driven innovations will help the civil engineers to solve the issues or challenges facing the industry. In our case, industry in our civil engineering, the industry will be infrastructure industry, infrastructure development, right? So I have chosen this topic because of the transportation engineering facing several challenges. Right. If you can look into this particular image, which was taken from ChatGPT, and this is an image which is produced from ChatGPT, is showing you the construction of a pavement, maybe a smart pavement, and will be utilized for the vehicular movement. Okay, and you can observe the construction aspects of this pavement, where no human being is involved in this pavement construction. Right? It might be a robotic technology which is employing the pavement construction, or a 3D printing technology which is constructing the layers, and it will be monitored by the computers, and it will be operated by the computer itself. So this could be the future of pavement technology, right? So how this will happen without being familiar with these technologies? That is the challenge of any civil engineer, right? So you might have several industry-driven innovations available, and you must be familiar with all these industry innovations, right? So Industry 4.0 is nothing but digitalization of the industry. So we have our industry, construction, infrastructure, transportation, transportation projects, etc. So these digitalization, digital innovations, how these innovations will help us in monitoring the pavement construction will be explained in today's session. Now, the entire outline of this presentation could be, I briefly introduce the topic and what are the Industry 4.0 technologies available in road construction, and what are the benefits of these Industry 4.0 technologies. And then I have chosen sustainable pavement construction because I'm specialized in the pavement engineering, where I have used several industrial byproducts in pavement construction, and hence I have chosen this important topic. And this topic is very applicable for civil engineers, particularly in our country. Then, and Industry 4.0 in managing industry byproducts for pavement. Now, what are the challenges of industry byproducts in India, and how the digitalized technology will help in solving the industry byproduct challenges? Then some case studies as of now in the country are real world applications and challenges and future directions, and then conclusions, right? Right. So as I said, Industry 4.0 will be the integration of various digital technologies, digitalization, as I mentioned. So when I mentioned digital technologies, what are the technologies? So we have Internet of Things, IoT. We have artificial intelligence, machine learning. We have building information modeling and big data analysis, robotics. In one of the images, I've shown you how the robotics will help in constructing the pavement, automation, then digital twins, where we can use VR and VR technologies in simulating the actual field problems, 3D printing, the 3D printing technology, how the 3D printing technology will help in the pavement construction, and the blockchain transparency in the material usage will be helping the pavement engineering. So these are the technologies now helping the construction industry. We'll see. Right. Now, at present, as I said, there are a lot of challenges faced by the Indian construction industry, particularly in the pavement side. There are various challenges where there are resource scarcity. Natural resources are depleting day by day. So no more natural resources, maybe in the form of aggregates. Those are depleting day by day. Now that is one challenge. Then greenhouse gas emissions leading to the pollution. So one need to reduce the air pollution. Then waste disposal is another problem in India, developing country like India, where it is a menace. It causes several hazards in the society. And finally, the durability aspect of the pavements. Right. Then there is another growing demand for infrastructure in any country, particularly a developing country like India. Uh, it lead to rapid urbanization. So the villages and small towns are emerging or converging into a big cities. Now, big cities are converted into mega cities. Mega cities will be converted into metropolitan. Metropolitan cities will be converted into cosmopolitan cities, and so on. And hence, we need a sustainable and durable pavement for this demand. Okay, that is another challenge we are facing now. Then there are natural resources which are depleting day by day as we are constructing large infrastructure projects, particularly national highways, expressways, state highways, port connectivity roads, etc. Even Sagarmala. So all the roads are national highways are going to be widened from 4 lane to 8 lane. Expressways with 12 lanes are provided. So it needs a lot of natural resources. So we are depending on the natural resources for the construction of these huge projects, maybe in the form of even we need cement in large quantities, bitumen which is imported from other countries. We need huge quantities. Okay, so the day by day natural resources are depleting, and there will be environmental degradation that will take place in the entire country. So leads to a lot of problems, right? Right. Then another thing is industrial byproducts are available in the country as in the form of waste product. Now, if you can utilize these industry byproducts in the construction industry, and these products can maybe converted as sustainable alternatives. Why we mention sustainability in this particular aspect? Now, sustainability is nothing but preserving the natural resources is sustainability. So preserve natural resources. That's it. That is sustainability in every aspect. That means use the waste products. In construction industry, use the waste byproducts from several industries as an alternative materials. So alternative materials, for example, natural sand will not be used, and instead of natural sand, use alternative materials. And cement production, so use less cement or no cement, which will be a sustainable development, right? So some of the sustainable alternatives we can look into the pavement engineering as a material. Okay, so you heard about fly ash. Most of the sustainable alternatives will mention the fly ash. It is a waste product from thermal power industry, various thermal power industries, and GGBS is also by industry byproducts of steel industry. Like you have Vizag Steel. Vizag Steel Factory is producing GGBS, ground granulated blast furnace slag. Silica fume is also another industry byproducts from steel factories. Rices gas is also a waste material. Okay. Now all these can be used as partial replacement of cement in pavement. So my entire research was on this industry byproduct utilization in the pavement construction. Then there will be waste from quarry stone quarries, stone crushing units available. And from the stone crushing units, this quarry dust is going to be produced, and it is also a waste product. And in the recent past, as I said, villages are converted into small towns. Small towns will lead to large towns, cities, mega cities, cosmopolitan cities, and so on and so forth. Even in the recent past, the government of India has introduced a concept of smart city construction. So, more than 100 cities in the country are converted as a smart cities, as a smart city, right? So, what is a smart city? That means they are converting the existing city into a smart city. In that particular case, several old buildings, right, which are not capable of withstanding the present loading conditions, will be demolished and will be replaced with new buildings with tall tower kind of structures. So they are just introducing tall towers of G plus 50, G plus 100 as a smart city and provided with all necessary facilities. So that is the concept of smart city. So within 2 or 3 kilometers square kilometer area, they develop a city, is a smart city. So the old buildings are demolished and construction demolition waste will be produced. And having huge quantities of construction and demolition waste, if we can utilize this alternative resources in the construction industry, particularly pavement construction, it will be a sustainable solution. And copper slag is also a product available from the industry. And again, one more important waste material, waste plastic. So waste plastic has been produced in tremendous quantity in the entire country. And if we can utilize waste plastic in a suitable manner in the road construction industry, it will be a sustainable alternative. And hence, we need to take the help of Industry 4.0 digital technologies to face these challenges. That this is my topic today. So all the students need to think about the industry byproducts and its effective use. As of now, the utilization of all these industry byproducts is not up to the expectation. Even 50% of these industry products are not used in the construction industry, and hence the research. Some research need to be conducted to utilize all the products by 100%. So that is the challenge need to be solved or need to be addressed by all the civil engineers and all the civil engineering community, right? So if you look into the problem of waste generation, no, this is a dumping yard where the city waste of the city are dumped at a location. It might have all kinds of waste materials, right? There are a lot of millions of tons of byproducts are produced in the form of waste. If they are not treated and then they are not dumped properly, there is a danger of land pollution. Definitely, there will be groundwater contamination and leads to health hazards. So we need to tackle this particular situation or this challenge. So how Industry 4.0 will help in solving all these problems. Right, Industry 4.0 technologies, as I mentioned, AML. So where AML, we have AML, Artificial Intelligence and Machine Learning, BTech program. Now all these BTech program students may not help us, but the civil engineer must have some knowledge on this AI and machine learning technologies just to have mixed design optimization. I need an engineer CSE student to help me in optimizing the mixed proportions. So you might have heard about M20 grade concrete, M30 grade concrete, M40 grade concrete. So some of the final year students are doing some project work in concrete. For example, they need to have optimized mixed design procedure. And manually, one cannot optimize the mixed proportions where we need to depend on some machines, computers, and AML will help you in optimizing the mixed design. So that is one advantage of artificial intelligence and machine learning in our pavement engineering. And we can predict the pavement performance, right? So how the pavement is behaving in the entire life period of, for example, 50 years. Now we need to predict its behavior, how it is behaving in the early day of construction, after 10 years, after 20 years, and after towards the end of the design life period, how it is behaving. So we can predict its behavior throughout its life, day by day, even hour by hour, also using this technology. And IoT and sensors will also be used in order to monitor the pavement construction quality during construction. There are several processes involved in mixing the materials, transporting the material, placing the material, and compacting the material, curing the material. These are various construction steps that are involved in pavement engineering. And we need to have a real-time monitoring whether quality product is transported from the ready mix plant to the construction site. It's going to be monitored, right? So it will be monitored with the help of Internet of Things and sensors. So yes, we have the advantage of IoT and sensors in construction industry. The big data analytics, as I mentioned, 50 years of life period we provide for any pavement. So throughout this life period, we need to assess the cycle cost analysis of entire pavement life period, and where we have huge data, and that huge data will be used for analyzing its life cycle cost analysis. Okay, so one cannot predict at the end of the life period how the pavement is behaving, and one should predict its behavior even after the life period. For that purpose, the entire data available will be analyzed. And building information modeling is the latest trend in the construction industry, particularly civil engineering construction, where we are integrating everything into one building information modeling. So we have a simulation of the materials and what are the alternatives, and also the maintenance planning will be monitored.
Hello, 1, 2, 3.
This building information modeling. Okay. And again, robotics and automation is another technology will be used in road construction. So the automation needs for precise optimization, either in material usage or precise aspect in the construction aspects. And again, as I mentioned, for sustainability in pavement engineering, the waste material processing should need to be very precise, right? So we have different waste materials available. One cannot use all the available waste material in construction. One need to choose the wise waste material according to their usage in the construction. So manually, one cannot separate the waste material. One cannot characterize the material, and one cannot optimize the mix proportions, and hence we need automation, right? So these are the technologies will help in road construction. So these are the definitions, particularly written with respect to pavement engineering, AML, Internet of Things and sensors, big data analytics, building information modeling, and digital twins. So we need to have simulated models before the construction, robotics and automation, 3D printing technology, additive manufacturing technology, which will be helpful in the speed in construction. Then blockchain technology, we need to have transparent technology which will optimize the construction materials. Yes, so what are the benefits? When we employ all the Industry 4.0 technologies in pavement engineering, what benefits we can arrive? So definitely there will be enhancement in the material efficiency, yes, and the performance of the pavements will be improved. Then it will reduce the dependency of virgin natural materials, as our intention is utilization of industry byproducts with the help of these technologies. So obviously reduce the dependency. There will be minimized environmental footprint through recycling and reuse. So carbon footprints can be minimized as we are using industry byproducts. So it will also enable the predictive maintenance and longer pavement life. So we can estimate or we can predict the maintenance required year by year for any kind of pavement, and hence the pavement life will be prolonged. These are the advantages of Industry 4.0 integration in the pavement engineering using the sustainable materials. So for today's presentation, I have chosen some of the industry byproducts normally used in pavements. Most of you know about these industry byproducts, fly ash, ground granulated blast furnace like GGBS. You heard about GGBS, copper slag, the waste plastics, construction and demolition waste, rises cash, and quarry dust. I quickly go through these industry byproducts where these products are available in India, how much quantity these products are produced in the country as a waste menace. Now you know about fly ash is a byproduct of thermal power plants. Okay, and most of the Indian thermal power stations, National Thermal Power Corporation, NTPS. NTPC is Thermal Power Corporation. Under NTPC, there will be several power plants, and these power plants are producing fly ash. State electricity boards also, and there are some private thermal power plants also producing fly ash. Now in India, and if you can see the amount of fly ash that is produced will in the range of more than 220 million tons. So 220 million tons fly ash is going to be produced every year. Okay, and if you can look at the utilization level is approximately 75 to 80% till now, and there are still 20% of unutilized fly ash is dumped in the yards, and hence it leads to several problems. And some of the states which are producing major fly ash. So these are the states producing major fly ash. Right, as fly ash as an engineering material, and we need to know the quality of fly ash. And when you know the quality of fly ash, and it can be used in various construction industries, I can use the fly ash for various purposes, right? Some of the physical properties I mentioned here, so will be required for the engineers to understand the material, whether the material can be used as construction material or not. We should know about these physical properties, right? And some of the fly ash materials are also pozzolanic in nature, class F, and some of the materials are also cementitious property when we add with cement, class C. And there are a lot of advantages using fly ash in concrete. Okay. Now, if you can look at the fly ash application in pavements, the fly ash can be used as a soil stabilization, right? So you just imagine the construction of a big national highway having 8 lanes, 4 lanes on one side, 4 lanes on the other side. And to construct such big highway, national highway, we need to have soil maybe used as embankment of height more than 1 meter and subgrade of half meter. So in this construction of embankment and subgrade of height 1.5 meter and of width around 100 meter, for example, we need huge quantity of soil as construction material. And this soil, when this soil is not satisfying the requirement, for example, silty soils or expansive soils, black cotton soils, which are not suitable as pavement material, you can use fly ash as stabilizer so that unsuitable soils can be used. So that is the application. And at present, we are using fly ash in the cement replacement of concrete pavements. Even up to 35% of fly ash cement replacement with fly ash is showing good results. Okay, as I said, embankment filling, highway fill material, you can use fly ash directly when the fly ash is available at that particular site, nearer to the site, and hence you can use it as an embankment or a fill material. Okay. Now Delhi Agra Expressway, where fly ash embankments were constructed. Okay, use even if you can look at the height of embankment, it could be around 3 meter to 4 meter height. It looks like an artificial hill. That embankment expressway is looking like an artificial hill where we use fly ash for that purpose. Now, as I said, roller compacted concrete pavement. This is an innovative kind of pavement where we can optimize the cement consumption with the help of fly ash in construction. Then subbases, will be stabilized, materials will be used, where fly ash can be mixed with aggregate, can be used. And at present, we use fly ash for bricks construction, brick manufacturing, building blocks manufacturing, even paver units, concrete pavers also we use fly ash. These are the applications of fly ash in pavement construction. Then coming to GGBS is a product of thermal power steel industry, Vizag Steel, for example, steel manufacturing industry, and a lot of industries are producing GGBS. Now, India is the second largest steel producer in the world, around 150 million tons crude steel annually produced by the country. Out of this, 30 to 35% of steel is produced, results in the slag. Okay, so slag is also produced in a quantifiable or in a reasonable waste byproduct. This GGBS 25 million tons per year is produced, and hence it can be used as construction material. Steel Authority of India Limited, Tata Steel, Jindal Steel, RINL, SR Steel. These are the steel industries, major industries in the country producing GGBS, and these are the states producing GGBS. Yes. So we have another industry byproduct can be used in construction. As usual, the engineer, civil engineer must know the properties, chemical properties we have, but physical and the engineering characteristics need to be studied by the engineer. Okay. And hence, by knowing its physical, chemical characteristics, engineering properties, you can judge the suitability of this GGBS in the construction. That's why you need to focus on the properties of the waste material available at any place in the country. Okay. Then if you look into the application of GGBS, yes, cement replacement, obviously. In the case of fly ash, I have mentioned only 35%, but with good GGBS, you can go up to 70% of replacement in concrete pavements, right? So straight away, as you are saving 70% of cement means it will reduce the carbon dioxide emission, okay? Then it can be used in roller compacted concrete pavements, okay? It will be used in overlays, white topping, soil stabilization. So mix the soil with GGBS, which will be improving the property of soil, and it is an alternative material. Even in the bituminous mixes also, GGBS is used as filler material. Maybe 3% or 5% of bituminous mixes will be provided with GGBS. And precast concrete blocks, you can use paving units. You can use. So these are the applications of GGBS. Okay. Then coming to the copper slag, maybe the production is 12 million tons per year, but still you can employ the usage of copper slag in construction, right? So wherever copper slag is produced abundantly in those locations, you just use copper slag as an alternative material, right? So, and as usual, as an engineer, you just observe the physical properties, okay? Look into the specific gravity, the densities, right? And the engineering characteristics, just to decide whether the copper slag can be used in concrete itself, can be used as a filler material, can be used as a stabilizer, etc., etc. All these things will be decided based on the properties, right? Then applications. So copper slag can be used in bituminous mixes, cement concrete pavements. The replacement is around 30 to 50%. Like fly ash, slag can be replacing cement up to 50% also. Then in pavements, you can use it as a base material or base course material, and it can be used as abrasive blasting. For example, runways where we need to have anti-skid surface with very strong surface force, which will resist abrasive action of the aircraft wheels, where we can use this copper slag. Interlocking paver blocks, as usual, it is common to all the industry byproducts. And even embankment landfills also use this resource, right? Then coming to waste plastics in roads. So most of the municipalities are producing the waste plastic, and the waste plastic is comprised of carry bags, packaging films, bottles, cups, sachets, multi-layer plastics, etc. Now, industries are also producing industry plastic waste, scrap from molding and extrusion. Then plastic industry is producing waste. So end of life plastic products, once the life of the plastic product is over, it is unused, maybe pipes, furniture, containers, chairs, etc. And so this waste plastic cannot be directly used in construction, but in some modified form, it can be used. Now, you should focus on the utilization of waste plastic in the pavement construction industry. And even you can choose some certain projects in this particular area so that it will help the country in the sustainability aspect. So India is generating 10 million tons of plastic every year. So 40% is single-use plastic, carry bags, packaging. Only 60% is recycled, but 3 to 4 million tons remain unutilized annually. So we need to concentrate, focus on this unutilized waste plastic in the pavement construction. Right, properties as usual, the engineer must look into the properties. Yes, the characteristics, engineering characteristics. At present in the construction industry, by just heating the waste plastic, converting them into liquid, and this liquid is added to bitumen, both are heated to a temperature, will be used in bituminous pavement construction. That is the usage of plastics as of now in the bituminous construction industry. But the problem is, as you're heating once again the waste plastic, it leads to emission of carbon dioxide, carbon monoxide into the air, which results in the increase of carbon footprint. So avoid such kind of practices, construction practices. Use the plastic without heating. Okay. So as I said, bituminous mixes, plastic roads, 8 to 10% by weight of bitumen, we add the waste material. And rural and urban roads, one can use this waste plastic roads laid already. Modified bitumen, so mix the bitumen with waste plastic. A new bituminous material is available, having superior quality polymer modified bitumen. Then composite pavement blocks, plastic plus aggregate fly ash mix can be used as concrete composite paving blocks or even tiles. Then the embankment landfills, plastics used in geomembranes, right? As a liners in the pavement drainage, one can use the plastic. Now, the important aspect of construction demolition waste, as mentioned, it is day by day the production of C&D waste is increasing at present based on the Central Pollution Control Board. India is generating 170 million tons of C&D waste per year. And this is the data of 2022, but at present, this has been increased. Okay. So this waste is generated from the construction, demolition of any building, any structure. And during renovation, we demolish certain components of buildings. And again, demolition activities will lead to the construction and demolition waste source. So concrete debris and bricks will be there in C&D waste, masonry will be there in C&D waste, steel will be there, timber, plastics, glass, maybe in the form of broken form, asphalt, tiles, ceramics, gypsum boards. Even the demolition waste may be comprised of some excavated soil and aggregate. So these are the major sources, major forms of C&D waste. Okay. Now, one interesting thing is major cities in the country have this construction and demolition waste plants. So Delhi, Mumbai, Bangalore, Hyderabad, Chennai, and Ahmedabad. And in Andhra Pradesh, even in Vizag and Vijayawada also, the city doesn't have any C&D waste producing units. So we need to procure C&D waste from these cities so it can be used in the construction. Okay. The properties. One should look into the properties as usual. So most of the demolition waste will not be homogeneous. Depends on source generation. For example, different if you demolish the old 100-year-old building, might have different combinations of materials. So if you demolish a 10-year-old building, the combination of materials will be different. So it all depends on the generation, source of generation. Recycled aggregates might have a lower density, but it might have higher absorption. So these are the two important points to be noted. And the strength will be around 80% of the natural aggregate strength. Okay. But you can use the recycled concrete aggregates for pavement layers. And if material is having acceptable CBR value, it can be used in subbase and base courses. So can partially replace natural aggregates in concrete, not fully, but in concrete you can replace it up to 30%. Okay. So in applications in pavement solutions, it can be used as subbase. It can be used in concrete pavements. Can be used as embankment and fill material. Lot of applications in pavement engineering. Paver blocks, precast products can be produced, and even bituminous construction also you can use recycled asphalt pavement wrap, right? And in urban roads, low volume roads, rural roads, village roads, other district roads, you can use the C&D waste. So similarly, rice as gas, similar kind of properties. And quarry dust is another source of industry byproduct. All stone crushing units are producing quarry dust. Okay. So the quarry dust might be a fine aggregate, less than 4.75 mm. Now India is producing 1700 million tons of aggregate annually. Out of the 1700 million tons, the quarry dust will be around 20 to 25%. So India is producing 300 to 400 million tons per year, the quarry dust. So we have huge source of quarry dust, and it can be effectively used in the construction industry. Okay. The properties, as usual, as you look into the properties, physical properties, most of the properties are satisfied with the natural aggregate. So quarry dust is going to replace the natural fine aggregate river sand. So you can stop excavating or dredging the sand from the rivers with the usage of this quarry dust, right? Specific gravity is similar to sand, fineness modulus is similar to sand, even bulk density is equal to sand. So all these are satisfying the requirement of fine aggregate, and hence you can replace the sand by 100% in concrete. So engineering characteristics are also suitable. So one can use the quarry dust very effectively in the construction industry. Okay. But the problem with the quarry dust is there might be high fines content. So 75 micron size of the percentage of fines content in the quarry dust is more, as the material which is passing through 75 micron size will not be used in the construction. So that is the limitation. Then there will be presence of silt and clay content in quarry dust, which will reduce the workability. Okay. Quality varies, depends on the rock source. Okay. Quality. For example, granite source will produce good quality of stone dust, and other sources may not produce the good quality. That is another limitation. So use this with washing. Without washing, it will not produce good results. And the problem is when we employ the use of quarry dust in construction, it will cause a dust nuisance. Dust is raised, and the quality of air is going to be affected, leads to environmental and health hazards near the quarries. Applications, fine aggregate replacement, even 100% replacement is possible with quarry dust. Bituminous mixes we use, yes, GSB also we use. In wet mix macadam layers also we use dust very effectively. Roller compacted concrete pavement we used 100%. Paver block making, tiles, curbs making, yes, we can use. Even for soil stabilization also, one can use to improve the properties of soil. So as of now, I mentioned around 7 industry byproducts. And if you can look into the order of availability, the construction demolition waste, quarry dust, fly ash, even waste plastic. So 1, 2, and 3, 4 are abundantly available in the country. So look into it and see that its effective utilization is very much important from the point of view of sustainability. Okay, so other products, GGBS, copper slag, rice ash, available in smaller quantity, but you should look into 1, 2, 3, 4. Right. So this is the final order I mentioned: quarry dust, C&D waste, fly ash, and waste plastics. This is the final order. This is the amount of waste product produced in the country annually. Okay. Now how Industry 4.0 is helping in this particular aspect of unavailability of natural resources. Right. Now, I quickly go through this. Industry 4.0 is managing industry byproducts for pavements in the form of solving the challenge. Now, if you look into the quarry dust, so I consider quarry dust is the prime source of industry, alternate material to natural resources. So that's number one. Now, the challenge is in India, it is overproduced. Okay, disposal in open areas is another challenge. And another challenge is lack of standard gradation. Now, how this Industry 4.0 is solving these three challenges, right? Look into this. Now you know about the properties, and you know about the sources, location, everything, and you know the application of these materials. Okay. The next is how Industry 4.0, the digital technology, is helping you in overcoming the challenges, right? So Industry 4.0, its role is employing IoT sensor and drones for real-time monitoring of quarry waste generation. So different quarries located at different locations in the country, but we need a common platform in order to monitor the quarry waste generation. When once the generation, the quarry waste generation is known, accordingly its usage will be fixed, right? And it will be diverted to that particular location where actual demand for quarry dust is there. So manually one cannot monitor, and hence using IoT sensors and drones employed around the locations, which will make the effective utilization, right? That is one aspect. AI-based gradation control, yes. For gradation, the CV analysis of material, one location is producing good quality of quarry dust. Another location is producing bad quality of quarry dust. What is the meaning of good quality and bad quality? So good quality of material is showing good gradation, particle size distribution. So if you can employ AI-based gradation control, you can use good material in concrete and bad material in the soil stabilization, and medium quality sand can be used as a pavement base courses, sub base courses, and so on and so forth. So manually one cannot decide the quality based on its sieve analysis. So we need to have a model which will be AI-based model, so that we can control the quality. Then again, robotics in crushing plants, stone crushing units. As stone crushing unit is producing quarry dust from different aggregates. So a stone crushing unit have been producing aggregates of different sizes: 40 mm size aggregates, 20 mm size aggregate, 10 mm. So different crushing units are producing different quarry dust, and hence there must be automated segregation of the dust from the aggregate. That may not be possible manually, and we employ robotics, right? So that is the help of Industry 4.0. So digital twins. So we need to have a simulation of quarry dust usage prior to its use in construction. So digital twins will help us in understanding the quarry dust use in pavements and even its durability prediction. Now, construction demolition waste. We have seen the properties and its application. Yes, it is producing second largest produced material is C&D waste, 200 million tons per year. And the challenge, if you look into this, is low recycling rate. So less than 1% is the challenge. Then mixed waste, as the demolition waste is comprised of all the material: concrete, broken concrete, broken brick material, brick powder, even plastics are also mixed in concrete aggregate and so on. So that is the challenge. Now, how this challenge will be solved with the help of Industry 4.0? Manually, not possible. You cannot recycle manually this particular demolition waste. Then how Industry 4.0 will help? So AML, image recognition, automated sorting of concrete. So by digital image processing, and with the help of AML model, the entire demolition waste is going to be sorted automatically. Concrete will be separated, metal will be separated, having the digital image processing. That is the use of AML, image recognition, help. And robotics, yes, smart demolition robots, small robots will separate the recyclable aggregate directly at the site manually. Difficult and not possible, where robotics will help in sorting the aggregate, construction and demolition waste, right? BIM integration, linking the material passports to track construction and demolition waste life cycle, right? So construction and demolition waste and its life cycle will be integrated through building information modeling. Okay. Then blockchain. So one need to have transparency in usage of the materials based on its quality. That will be possible with blockchain technology. So the perspective of the use of AML, robotics, and blockchain, big data, etc., from the computer science point of view is different. From application point of view will be different. So we are using the end product of these technologies, right? And how it will be helping the construction industry is to be looked by the civil engineering community. Then fly ash, the challenge is storage in ash ponds leads to several problems: the ground pollution, air pollution, and so on. And fly ash is produced throughout the country in all thermal power stations, but having uneven quality. That is another challenge. Low utilization. So 60%, 70% utilized, remaining 30% unutilized. Then how Industry 4.0 is going to be help? So big data analytics, which will map fly ash availability near power plants to demand hubs. So demand hubs normally ready-mix concrete plants, and demand will be in the road construction industry. Accordingly, it will be diverted. IoT quality sensors will be monitoring on-site testing for fineness and loss on ignition and reactivity. So fly ash chemically need to be tested at the site itself, not to go for testing in the laboratory. And this IoT quality sensors available to monitor its quality even at the site. That is advantage. And AI mix design optimizers, as I mentioned, manually one cannot optimize the mix proportions. So with the help of AI mix design optimizers, you can suggest the best mix, utilizing less cement and utilizing more industry byproducts, which will make strong, durable concrete. So it will help. Then digital platforms, maybe real-time trading marketplace for fly ash to reduce the wastage. So these are the Industry 4.0 technology help in addressing the fly ash. Then waste plastics is another problem. The problem is mismanaged plastics causing environmental hazards. So management, solid waste management, and inconsistent processing. So we have processing units converting plastic into different forms. So there is some inconsistency in the processing units. Now, how Industry 4.0 will help in addressing this? AI sorting systems. Okay, it is separating the polymers, PET, PET bottles, LDPE, low density polyethyl, high density polyethylene. So we need to separate them using this technology, and accordingly it will be used in the road construction. IoT enabled pyrolysis units convert plastics into fuel and construction additives. That is another help. Then 3D printing with plastic, use of shredded plastic, and will be used in 3D printing pavement block. So for 3D printing technology, 3D printing concrete cannot be produced, but 3D printing modular plastic bricks can be produced, as the material is just plastic with one more material, either mortar or sand, etc. So blockchain is again will help in addressing the problems. Track plastic producers' responsibility in road construction use. These are the Industry 4.0 help. GGBS also same, IoT quality monitoring, digital twins, predictive logistics. Copper slag same, rises gas also same. So overall, we can look into how Industry 4.0 will help in addressing the challenge. IoT plus sensors, real-time quality monitoring and waste tracking, AML, smart mix designs, predictive maintenance, automated sorting, yes. Even digital twins will employ in virtual pavement models to test durability before construction. One need to have the digital twin virtual pavement models. Blockchain, transparent supply chain for byproduct use. Once the byproduct is ready, it will be used effectively and in the construction industry without having any doubts. Building information modeling integration for life cycle management. Okay. And robotics and automations, efficiency, recycling, demolition, and material processing. So these are the Industry 4.0 enablers, which is helping sustainable pavement in pavement technologies. Now, there are some case studies where in India, some of the projects have been employed using this Industry 4.0 help, right? So one such case study, fly ash concrete pavements monitored by smart IoT sensors in Indian highways. So use of GGBS in urban road construction with AI optimized mix design, another case study, and real-time application. Autonomous machines laying modular pavements with on-site 3D printing, another one. Digital twins, this is another case study. I may see one or two. So this was the case study of fly ash concrete pavements with smart IoT monitoring at National Highway 33 Jharkhand state. This was the image of that particular project where we see the features of this particular project. It was located in Jharkhand state, NH 33. It is a 5-kilometer pilot project. The sustainability aspect in this project was fly ash was used 35% replacement in concrete, and hence there will be reduced clinker use, reduced carbon dioxide emissions, and ash disposal. These are the sustainable aspects of this particular project, and they provided rigid jointed plain concrete pavement surface with fly ash dry-lin concrete subbase course and designed as per the guidelines, Indian Roads Congress guidelines. Now, the digitalization, IoT sensors, they deployed temperature and maturity loggers where the sensors are embedded in the concrete pavement in order to predict the early strength gain. Some strain gauges were used to know the slab stresses and the temperature variation, as well as wheel load application. They observed. Humidity probes also kept inside the concrete, even at joint sealing. For joint sealing efficiency at the joints, humidity probes were inserted. Okay. So MEMS accelerators for understanding the amount of traffic moving on that particular stretch and vibration of the pavement under the traffic movement are also monitored. So temperature, strain gauges for stress, and humidity probes to know the joint sealing efficiency and the traffic measurement continuously. They deployed sensors. So from the sensors, whatever data they collected is connected to the cloud dashboard, and real-time analytics were available, which will predict the behavior of the pavement during its life period. So the key outcomes is earliest traffic opening. Normally, one need to wait for at least 1 week to open the traffic, but with this help, with the help of these sensors, as we predicted the strength gain, even with 3.5 days, half of the time period the traffic is allowed is advantage. and condition-based maintenance alerts. So as it is predicting the behavior day by day or on hourly basis also, so we can choose the maintenance requirement depending upon the condition. So 4,500 tons of fly ash were used, and there will be 1,900 tons of carbon dioxide savings just in 5-kilometer stretch. That was the case study. So, and another case study, use of GGBS in urban roads, construction with AI optimized mix design. So AI based model was used in this particular construction of urban road. So this was 2-kilometer urban arterial road in Bengaluru. It is under smart city mission. They used 40 to 50% replacement of cement with GGBS. That was the material innovation. Because of this, reduced clinker demand and reduced heat of hydration advantage, and improved durability also because of this GGBS. They employed AI optimized mix design. So manually, it is not possible to optimize the mix design. I mentioned. So they optimized the mix proportion, cement, GGBS, fine aggregate, coarse aggregate, and even water cement ratio. And finally, they arrived at an optimized mix proportion, which will produce you the required strength, the given workability, and less cost. So M40 grade concrete was produced with 12% lower binder cost and reduced CO2 footprint. For example, when we use M40 grade concrete manually designed, then with the AI model, it reduced around 12% lower binder cost. That is the positive point of this case study. And performance monitoring, they used sensors, non-destructive tests like ultrasonic pulse velocity for compressive strength, flexure strength validation. They used AI predicted around 50 to 20% longer service life compared to the conventional OPC mixes. So the benefits of this case study was sustainability, economics, and scalability. So these are the advantages of employing Industry 4.0 driven technologies in pavement construction. So focus on these kind of project works in your final year. So another autonomous machines with on-site 3D printing for modular pavements. 3D printing technology. This was demonstrated as a pilot project in Pune Smart City Industrial Corridor. So autonomous paving robots equipped with AI navigation, LiDAR for precision alignment surveying. Then on-site 3D concrete printing paver blocks were used, right? And there will be automated placement and compaction units integrated with robotic arms. So these are the three technologies were used at this case study. So innovation will be eliminates need for centralized precast yards, on-demand modular unit printed at site. No need of a separate yard for the production of precast blocks. So even at the site itself, using 3D printing technology, you can produce the blocks. AI digital integration. So AI optimized path planning for robots. Digital twins to simulate the load transfer, durability, and optimize joint layouts before construction. Digital twin technology. And the performance, if you look at 40% faster installation than conventional advantage. Reduced material wastage by 25%. Early life monitoring. And the benefits its speed in construction, sustainability, and scalability. This is another case study. So Delhi Meerut Expressway, where the case study was digital twins for pavement behavior and predictive maintenance. So they used digital twin models, which were built from IoT sensor for data collection, traffic counts, climate inputs. Climate data is also needed. AML algorithms, which will simulate distress progression, how the cracks will propagate, whether the cracks are generated on the surface itself or extending into the inside the pavement layers, the rutting phenomena under the load application, joint failures, if any, are observed through AIML algorithm. The innovation in this project was real-time integration of strain, temperature, and traffic data they monitored, and virtual model mirrors actual pavement. And based on this data, it will predict the failure points on that particular pavement. Accordingly, it will be maintained. The key outcome is 30% reduction in maintenance cost, obviously, 15 to 20% extension of pavement service life, and there will be shift from reactive to proactive maintenance planning. So maintenance is very much essential feature in pavement engineering. It will be made possible with the users of this technology. So obviously life cycle cost savings, less traffic disruption, and reduced material consumption and carbon dioxide emissions. Right. Coming to the challenges and future directions, you cannot directly use these digital technologies in the construction industry, but there are some challenges. There will not be any standardized and regulatory acceptance by product use. So at present, Indian government has not been published any guideline or a specification for the utilization of these industry byproducts in the construction. That is the challenge. High initial investment in Industry 4.0 technologies. As I mentioned, digital twins, IoT, sensor deployment, AML model, algorithms, etc. So it is not possible without investing money. So that is another challenge. There will be skill gaps in workforce, right? As we employ only civil engineers without the digital technology knowledge, and one should recruit the people from computer science to solve these kind of problems. So there is skill gap in workforce, and then need for cross-sector collaboration. So we need to collaborate. Otherwise, we need to learn the digital technology also. The future directions are strengthen academia, industry, government partnership. Yes. So the engineering colleges need to interact with industry, knowing the industry challenges, solving the industry problems, using the digital technologies, and same thing will be communicated to the government, state government or central government, so that we can solve these problems. Then upskill the faculty. Yes, faculty need to be updated to these digital technologies, Python coding and AML, machine learning methods need to be studied by the faculty, right? Similarly, IoT, etc. So the students need to acquire the knowledge, these technology knowledge, in the form of global certifications and in the form of studying minor programs, etc. And industry professionals need to learn these skills. Okay, scale adoption of smart materials and digital tools for sustainable infrastructure. So these are the future directions which will help in the sustainable pavement engineering. Then conclusions as of now. Finally, Industry 4.0 technologies are revolutionizing pavement engineering. Yes, there is a revolution in the pavement engineering, which will enable smart, efficient, and quality-driven construction. Okay, so we can increase the pavement life, pavement quality, and the use of efficient material usage. The use of industrial byproducts. All these byproducts offer sustainable alternatives to traditional materials, fostering resource conservation and waste valorization. Yes, that is another important conclusion. Digital innovation support real-time quality assurance, predictive maintenance, and optimized material designs, which will enhance pavement durability and reducing environmental impacts. So addressing challenges such as regulatory standards, investment costs, and workforce skills is critical for widespread adoption. Still in question in India, this conclusion. So strengthening the collaboration between academia, industry, and government will accelerate the transition towards resilient, eco-friendly, and cost-effective road infrastructure. These are the conclusions. Some of the references. And yes, I conclude my presentation. And if you have any questions, you may ask.
Sir, one doubt, sir.
Yes.
Sir, ఇప్పుడు సస్టైనబిలిటీ మెటీరియల్ యూస్ చేయడం వల్ల కాస్ట్ ఎంత తగ్గుతుంది సార్?
It depends on the type of project, Amma. For example, in concrete pavement, if you can replace the cement by 30% means we can reduce the cost by 20%. It all depends on the availability of that material. How much at what cost this industry waste product is available. In some areas, the industry waste product is available at zero cost. Zero cost means the industry is giving the byproduct waste product at zero cost, but the cost is transportation from the industry to this plant or the construction site. That is transportation cost. If that industry cost is zero, transportation cost is more, then the cost saving will be less. Likewise, there are a lot of issues involved in calculating the cost of the product. There will be
Sir,
definitely there will be saving. There will be saving.
ఓకే సార్, థ్యాంక్ యూ సార్. ఇప్పుడు రోలర్ కాంపాక్టెడ్ కాంక్రీట్ కి నార్మల్ కాంక్రీట్ కి వేరియేషన్ ఏంటి సార్? అండ్ కాస్ట్ వేరియేషన్ ఎట్లా ఉంటుంది?
Normal concrete pavements are jointed pavements with M40 grade concrete laid as pavement quality concrete, where we use a minimum cement content of 350 kg to 375 kg per cubic meter. But when we use roller compacted concrete with 300 kg of cement, we can produce same quality of concrete. So there is a clear saving of 50 to 75 kg of cement. That is in materials wise comparison. But roller compacted concrete pavement can be constructed using rollers. A roller is employed to spread and compact the roller compacted concrete material, like bituminous pavement construction, where we spread the material using pavers and we compact the material using the roller. But in concrete pavement construction, the compaction is employed by using vibrators, needle vibrator, flat vibrator, table vibrator, etc. But here in the roller compacted concrete, we can compact the concrete by roller, a big vibratory roller. That is the difference. And it is easy to construct. No formwork is required. And it is easy. I mean, early opening is possible. No jointing in concrete. These are the advantages of roller compacted concrete pavement.
సార్, ప్రెసెంట్ ఇండియాలో ఓన్లీ కాంక్రీట్ యూజ్ చేస్తున్నారు కదా, రోలర్ ఎక్కడైనా యూజ్ చేస్తున్నారా? దాని రిజల్ట్ ఎట్లా ఉంటుంది సార్?
In Mumbai Pune Expressway, you heard about Mumbai Pune Expressway, which was the first expressway in India with concrete pavement. First expressway in the country was Mumbai Pune Expressway with concrete. So in that case, that concrete pavement was made with the M40 grade as a top layer and dryline concrete as a sub base below it. And that dryline concrete base was roller compacted concrete pavement, which was used in Mumbai Pune Expressway. Now that expressway is still existing. So, and several Pradhan Mantri Gram Sadak Yojana roads were roller compacted concrete pavements. Most of the MP, Madhya Pradesh PMGSY roads were roller compacted concrete pavements. But still in India, standards are not available to implement this pavement as main pavements. Still research is going on, and your HOD sir and myself did several research works on this roller compacted concrete pavement, and finally we arrived at optimizing the roller compacted concrete mix with usage of fly ash up to 40% and GGBS even up to 60% can be replaced. But still the governments are not able to allow this replacement in roller compacted concrete pavement. That is the problem in the country, where the government of India is not able to implement this research finding immediately in the projects. But in some other countries like China, they implement even within six months the technology, whatever technology developed by the researchers, they implement immediately. But in India, it is not possible to implement the research findings.
థ్యాంక్ యూ సార్.
So you are from final year, Amma?
ఎస్ సార్, ఎస్ సార్.
Okay, okay. So any questions, Chiranjeev sir?
No queries, sir.
Okay.
We are going to wind up the session, sir.
Yeah, please.
As we come to the close of this insightful webinar, I take this opportunity to express my heartfelt gratitude. First and foremost, I extend our sincere thanks to Professor Krishna Rao sir for sharing his valuable knowledge and experience with us today. Your session has truly enlightened us on the role of Industry 4.0 in pavement engineering and sustainable road construction. I also thank our respected Dean and Head of the Department for their constant support and encouragement. A special thanks to all the faculty members and students for their active participation, which made this season meaningful. I also thank the coordinators Chiranjeevi sir and Anil sir. With this, we formally conclude